I would like to take the next 10 minutes to share our view how this ecosystem has been driving network innovation and why network innovation, especially in the 5G under the leadership of CTIA, is so important to the adoption of AI. And it is important for our nation to win in this global race of AI. So the history of this whole network infrastructure we've been driving innovation for decades. It proliferates all the way from the device to the network, to the core and RAN, and even your DOS system, and all the way to the private and public cloud. We are the linkage of all of the things that's happening from the cloud to the edge to your devices. And Intel has been, for the past 30 years, been participating, actively investing in both the silicon platforms as well as software, along with all our ecosystems. And we've been playing a very key role in this. And this innovation has not slowed down at all. In fact, this innovation has been greatly at leap and bounds because of the AI. AI has been the driving force to drive a lot of the intelligence moving from the cloud all the way to the edge. So I would say the role of wireless innovation is anything but leaping because of AI. It is an essential part of the AI. So let's talk about the societal shifts. As Intel, we are in the forefront of this. We're seeing a lot of the data is being generated on the edge. And it is because of the latency requirements, it is being computed on the edge. And there's a lot of, if you looked at the world has changed recently because of OpenAI, because of everything that's happened, and also the fact that we have seen a lot of onshore manufacturing. For example, Intel ourselves are building foundries, state-of-the-art foundries in Columbus, Ohio, in Oregon, in Arizona. All the onshore manufacturing and the supply chain bottlenecks require us to rethink about how we build out our infrastructure. AI becoming infusing all of the things that we're doing, not just fully automated. I don't know if you've seen some dark factories in China. Here in the United States, I'll have an example to show you later on. We are achieving, in some cases, 95% automation in the new factories that we're building. That is a remarkable effort. And because of that, we are seeing wireless playing a huge role as we migrate from agentic AI all the way onto what we call a physical AI. So I list some examples here that some of you are already familiar with, all the distributed assets, the security and network at the edge, a lot of low latency, and all of this is being enabled because all of us that on stage, all of us that work together has been driving a digitalization, like our CEO, Ajit Pai, has been talking. We have been investing in a digitalization and automation to enable what we're gonna see as physical AI. So the pace of innovation, as I mentioned, it has been done in parallel. The network has been investing heavily on innovation. In parallel, we're seeing the AI that move from the cloud, the hyperscale AI, down to agentic AI. And we see more and more of physical AI. In fact, I think in a week or so, there is an event in Detroit, Michigan, talking about humanoid robotics. He'll talk about robotics being part of the manufacturing plant, especially in automotive. None of this will be possible if this whole ecosystem did not invest in a digital transformation in our network and therefore bring it into the enterprises. What has artificial intelligence we've been benefiting in the RAN? Iban talked a little bit about it, and Igal also mentioned that AI in the RAN is happening. So we have been working with all of them, the operators here, AT&T, Verizon, T-Mobile, and Boost Mobile, Dish. We've been working on this AI in RAN itself. And I totally agree, AI RAN is being benefited because Open RAN and virtualized RAN, the work that we've been doing for the last few years, is really being able to accepting new applications. We see energy savings that Jen talked about as the first benefit, but we also see predictive analytics and all the controls, and also we also investing in some traffic steering, probably a better use, optimized use of spectrum for the right use cases, the right time. So all of these are the first path we see AI in RAN. And then I'll go further in saying that when we look at AI, how do we do the potential, how do we benefit from the potential AI? We look at 4 different categories. Number 1 is the compute resources. The best performance and power, especially as on the edge, is integrating the AI acceleration right in the CPU. And Intel actually announced that with the Xeon, the latest Xeon 6 SoC with AI acceleration right in the CPU itself. The other one is software stack interaction. Deploy closest to the software, give you the best control of the ARM or SLM model. Execution frequency, if models need to run infrequently, best to be run at the cloud. But what needs to be run more frequently, such as determining the channels for the wireless condition and closest, and has a latency requirement, probably best closest to where it needed in the radio itself. So I want to give you a couple of examples how AI and network has been transforming not just the wireless industry dealing with the consumers, but we have examples we're working with the enterprises that are using 5G and AI to solve problems. The first one I'll present to you is Miami International Airport. It's a 3,300 acres in the Dade County, Miami. It's a land-bound that you can't expand much anymore. In order to double the capacity without doubling the land, we're using together with our ecosystem, such as Nokia here, we're working with the Miami Airport to implement a 5G network, heavily use edge AI application to modernize their operation. You can see the examples here, such as the turnaround trackers, benefiting the consumers, the flyers in the airport, as well as the tenants, the airlines, the retail shops, the restaurants. Everyone there get their data and get to be able to analyze the data and reinvest their data effectively. So all of this is a way to improve their efficiencies. The other example I show is the Hyundai Motor Group Metaplant outside of Savannah, Georgia. This is a really good example when we onshoring manufacturing. How do we overcome some of the perceived higher labor costs, lack of maybe labor, a lack of skills? Is heavy driving automation. This is an advanced smart factory example. Similarly, we're using the same thing in the Arizona foundry plant that we're building outside of Phoenix. Intel CIO is investing heavily. We're working with Ericsson to modernize, on the get-go, a fully automated factory, building the most advanced silicon here in the United States. So these examples are showing without the connectivity, without a pervasive connectivity that this ecosystem invests, we will not be able to effectively modernize our factory. We will not be able to effectively leverage all the edge AI application that we have. So with the end, I just mentioned that AI doesn't happen unless you put it into the CPU itself, in addition to GPU, to reduce the cost and the power. So Intel's latest Xeon 6 SoC has AI instructions as well as AI acceleration right in the CPU. With that, the summary is we have a long history of compute. We're investing collectively with the ecosystem the 5G native in transformation that we've been undergoing for the last few years really get us to the point that we are fully able to leverage the AI investment the ecosystem has put together across the United Nations. It is very important we have a spectrum of pipeline of spectrum, because without it, we would not be able to deploy more network and really drive our nation to the forefront of this AI global race. Thank you very much.